Assalamualaikum and hi, my name is Afiqah binti Zulkifli and my group members Nur Fathihah binti Mak Fauzi. We are from the MK4A and today we're gonna present about speed and position control. Speed and position control. A typical DC servo motion control system need to consider to control the speed and position of the DC motor. There are 5 basic elements in a DC servo system. The first one is personal computer. Second, motion control. Third, power amplifier. Fourth, motor. And the last one is motion sensor. We go to amplifier. Amplifier receive the command signal from the motion control within range plus minus 10 volt and amplify it to the required current or voltage to drive the motor. Commercial amplifiers can operate in 2 modes. The first one is voltage mode, which is monitors voltage applied to the motor. The second, current mode, which is monitors current supplies to the motor. There are 2 types of amplifier. The first one is linear amplifier. It produces constant voltage or current. The second one is PWM amplifier. Utilize chopper to generate voltage or current. Amplifiers operates in analog mode. It receives an analog motion command that represents the desired motor velocity range of plus minus 10 volt. Positive 10 volt commands the motor in the full forward velocity, while minus 10 volt turns the motor in the full reverse velocity. Digital amplifier is new into the market scene. It receives digital motion commands as in stepper and this simplifies controller design. Currently, digital amplifier is used more in conjunction with DC brushless servo system. Next, we go to motor. The motor is an actuator that produces mechanical power. The key parameters of a DC motor. The first one is torque constant, KT. The second one is armature resistance, RA. Next, moment of inertia, JR. And next, peak torque, TP. And the last one is continuous torque, TC. Motor can generate any level of torque below the peak torque. The root mean square, RMS, value must be within the continuous torque to avoid overheating. Next, we go to position sensor. The position sensor can be incrementally encoders, absolute encoders, or resolve. The use of incremental encoder is most common. And next, controller. The controller is an intelligent element which commands the motion. It generates a signal to the amplifier, commonly analog. The fundamental task is to decode motor shaft position and close the loop. It also performs profiling function and communicates with the host computer.
Inertia. The inertia is one of the properties of a load in a servo system. Inertia is defined as the property of an object to remain in the present state of motion unless acted by an outside force. Rotational inertia is a function of the object mass, the shape and the mass distribution. Figure shows several objects that possess inertia. Figure in this slide shows the commonly encountered motion drive system and its load inertia. A. Belt drive. B. Linear slide. C. Rack and pinion. D. Gear train. Friction. Friction exists in all moving parts. Friction is the resistive force which acts to dissipate the energy of a moving system in the form of heat. It can act either to cause motion or retard motion. Frictional force consists of three components. 1. Static friction. Static friction, sometimes known as breakaway force, is the force which must be overcome to set the object in motion. It vanishes as soon as the motion sets in. 2. Dynamic friction. Dynamic friction is the force required to keep the object in motion in a viscous medium. The magnitude of this friction varies with the speed. 3. Column friction. Column friction is caused by static present between two moving surfaces. This isn't an opposing force that remains constant at all speed, including zero. Servo tuning. Any closed-loop servo system, whether digital or analog, requires some form of tuning. Tuning is the process of adjusting the characteristic of a servo so that it follows the input signal as closely as possible. A servo system is error-driven. In other words, there must be a difference between the input and the output before the system will begin moving to reduce the difference. The height gain system produces height correcting torque when the error signal is small. A height gain, therefore, is able to correct the output to follow the input faithfully with minimal error. A motor has both its load and rotor inertia. The amplifier must accelerate and decelerate to attempt following the input. In the process, three possible conditions may arise. A. Undamped response, in which system tends to overcorrect. Such gain is too high. B. Overdamped response, in which the system is sluggish, responding slowly to the error feedback. C. Critical damping, in which the system has the fastest response with little or no overshoot.